Hello children, the continuation of laws of motion in that friction. What is friction? Static friction we can see. See, friction which is nothing but whenever a body which moves or tends to move over the surface of another body, a force comes into play which acts parallel to the surface of contact and opposes the relative motion. This opposing force we can call it as friction, right? Now we can see through some example like a different friction, like static friction, limiting and kinetic frictions, like one by one we can see now. See, consider a wooden block which is placed over a horizontal table and apply a small force F on it. The block which does not move, the force of friction F which comes into the action which balances the applied force. See, the force of friction which comes into play between two bodies before one body actually starts moving over the other, which we can call it as a static friction, that is Fs. Okay. See, the static friction opposes the impeding motion. That means the motion that would take place under the applied force if friction were absent. That means, so as the applied force on the block which is increased, the static friction Fs is also increases to balance the applied force and the block does not move. Once the applied force is increased beyond the certain limit, certain force which we have given, the block just begins to move. So this stage we can say that the static friction is maximum. So the maximum force of static friction which comes into play when a body just starts moving over the surface of another body, we can call it as, that is a limiting friction. Understand? So these are all the points we can write for that. So the static friction does not exist by itself. It comes into play the moment there is an applied force. So what we said, the F is increases, the static friction is also increases. Got it, children? Now we can see, since the body is at rest, what we said, the friction which called static friction. So since the body is at rest up to the maximum limit, so that is limiting the value of static friction. Static friction, what we said, that is impeding the motion. The impeding the motion, that is nothing but the motion that would takes place under the applied force if friction were absent, which means, right? So when the applied force F which exceed the limits, the body begins to move, which we see, right? So what are the laws of limiting friction when it's applied? If suppose the Fs, that is the static friction, is independent of the area of contact and it varies with the normal reaction force is approximately as Fs, which is maximum, directly proportional to the force N, and also the static friction which is equal to mu s into N. The mu s which is nothing but the constant, proportionality constant, and it is depend only on the nature of the surface in contact. So mu s which is equal to, we can say, Fs by N. Got it? And mu s which is called as a coefficient of static friction. Now what is sliding friction, or we can call it as a kinetic friction, right? So if the applied force F exceeds the limit, what will happen? The body begins to slide on the surface. When the relative motion has started, the friction force decreases from the limiting value of static friction. So frictional force that opposes relative motion between the surfaces in contact, that is called kinetic or sliding friction, and that is denoted by F vector, Fk vector, and we can see what are the laws of a kinetic friction. So we can say that is the kinetic friction that is opposes the relative motion, and it has the constant value, and it is depending on the nature of the two surfaces in contact, we said, right. So Fk, it is independent of the area of contact, right, and it is nearly independent of the velocity also, we can say, and it varies with the normal reaction of force, right. So Fk, which is directly proportional to n, or we can say Fk, which is equal to mu k into n, as mu k is the constant, proportionality constant. So mu k, which is equal to Fk by n, as we know. Mu k is called as a coefficient of kinetic friction, and mu k is less than mu s, this you must know. And when relative motion has begun, the acceleration of the body is F force minus Fk by m. For a body moving with constant velocity, that time F, which is equal to Fk. So if applied force on the body is removed, then acceleration A, which is equal to minus Fk by m, and the body eventually comes to rest. So the laws of friction do not have the status of fundamental laws like those for gravitational or electric or magnetic forces. See, they are empirical relations that are only approximately true, but yet useful in mechanical applications actually, right. Now we can see what is rolling friction. The rolling friction, which is nothing but a body which is like a ring or a spherical rolling without slipping over a horizontal plane, or will not suffer the friction. So we can say that at every instant there is just one point of contact between the body and the plane, that the point has no motion relative to the plane. So in this ideal situation, the kinetic or static friction is zero, and the body should continue to roll with constant velocity, right. So the body which is rolling, and each and every point which is get contact, you can get the idea by seeing these two examples, at all the points which is when it is rolling and it is moving, only one point which is contact with it. However, in practical this does not happen, and the body comes to rest actually, right. Eventually it will comes to rest. To keep the body rolling, some applied force is needed. So this indicates that there is a rolling friction through, it is some smaller by 2 or 3 orders of magnitudes than the static or sliding friction, right. See this example. By the example you can understand that the rolling friction has a complex origin. During a rolling, the surface in contact get momentarily deformed a little, and this results in a finite area of a body being in contact with the surface. So the net effect is that the component of the contact force parallel to the surface opposes the motion. So friction is a necessary evil, need or not, it is we can see in many situations friction has a negative role. It opposes relative motion and hence dissipates more power in the form of heat, like in a machine with different moving part, and it causes wear and tear machinery parts in contact and the tire of automobiles. In many practical situations, however, friction is critically needed. For example, like brakes in machines and automobiles use friction to stop the motion of them, and we cannot walk without a sufficient friction with the ground or the surface. It is impossible for a car to move on a slippery roads. Like we can see a more and more example of the friction gives the important role in our day-to-day life. Like next one is, on an ordinary road, the friction between the tire and the road provides the necessary external force to accelerate the car. Thank you, children.